All right, welcome everyone. Give it a sec for everyone to come in. All right, why isn't LinkedIn starting?
Yeah, it seems like we have some issues with the link then.
Should I stop and restart it?
No, I think we have to start webinar here, and once the webinar will be started, and streaming will go through. Oh, we have people, right?
Yeah, nope, the webinar started. I don't know why the stream isn't connecting.
So let's do that. Let's share the Zoom link on LinkedIn just to allow people to connect, or we just need to wait a bit till LinkedIn will start streaming at 2 p.m., but I don't think so. It doesn't work. Now it's pre-live. It means that you have to click live on LinkedIn and everything will be there.
Where do I click live?
Should be the button there on LinkedIn.
I do.
LinkedIn streaming and then get live.
Where is that?
I can see your screen, but it should be there.
Sorry, in the Zoom?
No, on LinkedIn.
Yeah, all I have here, control, refresh. I do not have a go live button. Manage attendees, invite, leave event. For the people on Zoom, I apologize. We're trying to get the live stream going correctly on LinkedIn.
Yeah. We did that multiple times. What changed?
We've done it every time.
Yeah, the pre-live here. Okay, let's just share Zoom link on LinkedIn just to allow people connect out of there.
Yep, give me one sec.
I think this is the only option. Is it for now? I don't know what's broken with LinkedIn, but something definitely broken, and people is asking for the link there.
Yeah.
Okay, it's 120 people online. Yeah, we definitely have to share the link. Okay, can you do that? Can you share the link?
I'm doing it right now.
Yeah. It's funny that LinkedIn shared in pre-live. The pre-live usually means that we just need to click one button to go live.
Yeah, there's I'm looking. I've hit refresh a million times to see if there's some button.
That's very strange.
Well, normally I just hit the restream from Zoom and it automatically triggers it, and I don't even have to.
And you can try to stream directly to LinkedIn using the LinkedIn link if you have that. Just push the third-party streaming service as LinkedIn, and the Zoom will stream directly to LinkedIn without restream service.
Right, stop live stream. It doesn't give me an option to do live on LinkedIn.
No, there is no live on LinkedIn. There is third-party live streaming service, and then you have to copy and paste URL and secret from LinkedIn and put it here. Almost the same as you did with Restream, but using LinkedIn link.
Oh, gotcha.
Yeah. And by the way, guys, can you see my screen? I just want to check that everything is okay.
Yep.
Cool. Yeah, we will still have some technical issues, but I hope we're good to go. In a couple of minutes, just get more people out to connect with us. We have 60 people here, so it means that people moved from Zoom,
Yep.
From LinkedIn to Zoom. It's good to have all of you here, first of all, because now in Zoom we can run polls and you can vote. On LinkedIn you can't. I don't know, we will fix this next time, but like we try to do your best to connect the last thing that we have to check is just to copy and paste URL from LinkedIn stream and service directly to Zoom. And if this option will work, we will see the stream on LinkedIn. Otherwise, just share the link. The people is constantly asking about the link.
All right. Yep.
Okay. That's very interesting though.
Yeah.
Okay, should we start or should we try something else?
I think we'll just start, and I'll keep an eye on the comments on LinkedIn and keep posting the link to here.
Okay, got it. Okay, let's start then. Thanks everyone for joining us. My name is Ivan. I'm here today to run this evolution of the API security webinar. Sorry for the technical issues. We can't stream on LinkedIn for some reasons. There is a, I don't know, we're usually good there. We'll fix next time, and if we'll find a chance, we'll stream the record there and you will able to see the recording right on LinkedIn. I hope that it's possible. Before we start, so please run, it's Rick, sorry, Rick, please run the poll. We have a question for you as a first starting point with the topic we have for now. So what do you think when the first API exploit actually was detected? So that's a very important question we have to ask because it instantly brings us to the evolution standpoint to know, like they usually think about the evolution is like if something like moved the state from one state to another, it's better to start with a starting point with the initial state. That's why we have the poll now. And the question is, when was the first API exploit published? As you think about that, there is a couple of options, technically like 5, 6 of them. Please vote. And in a few minutes, once the voting session will be stopped, we'll move to the results, and then I will explain the truth when it happened and from where actually we go in this direction with an API security. First of all, definitely API exploits, not like directly means API security, like definitely this topic was in a map on a table early rather than the first exploits. However, the first exploit date is kind of like the good starting point from where we have to track actual results, actual researchers' efforts in this direction. Plus, it will allow us to like start this the pitch about the evolution of this API security from early days. Just a couple of minutes more to allow you to vote. And by the way, guys, if you just connected and you don't know as well as we don't know what happened with LinkedIn, please share the link for the Zoom with your friends and colleagues who might be interested in cyber security and or API security or application security, which is still the part of the topic for today. It will be great to see all of you here. They're just good to have more audience and 110 people online. That's awesome. Thanks everyone who joined us today. Again, sorry for the technical issues with LinkedIn. Sometimes the streaming service is doing some incredible job with their tab. And again, please vote on the poll. We have to find a way when the first API exploit was published. And then we'll start with this starting point to basically explain from where and to where it goes. For the people who just joined us, my name is Ivan and I'm running the session today. I'm a technical expert, researcher, cybersecurity researcher, and also CEO of the company called Wallarm. We do have an API security product. However, today I mainly will explain like an industry issues, why we decided to build a product, which challenges we face with, how we solve that and stuff like that. And if you never vote for the poll, please do that now. Otherwise, we will finish the poll in just 1 minute, 1.5 minutes, directly at 2:10 my time. It's Eastern time. If you connect from somewhere else, please share from where you connected. It's very important to know our audience. And then we will start in just a few seconds. 120, 128 people connected online. That's a lot. Since everyone, let's hit 200. Again, if you want to share the link with your friends and colleagues, people who might be interested in the topic, please do that now. That's very important to have all of you here. And then, unfortunately, we don't have the online on LinkedIn. We'll fix that if it will be possible. Most likely, we will afterwards stream the recording right there, and you will be able to see that on LinkedIn Live as well. Okay, let's start then. Rick,
So
could you
do
please
you have the
share
poll
results of the
results?
poll?
Yeah. Yes, I am.
Okay, let's share the results.
All right. So out of the 100 and here in the poll, can you see the results, Ivan?
I can see the results now. Give me a chance to find that. No results for me.
Okay. So out of the 104 people that that chose to do the poll, 54 of them got it correct, which is 1998.
Nice.
So,
1998.
yeah,
That's
so
a lot.
about half of them got it right.
That's a lot. True. So that's, first of all, I think that some of this folks already joined previous events that I run about this 10 years of an API security review, but you're definitely right. The first API exploits that we were able to find dated 1998, and they basically reported 1998, and then year after got published as a CVE, and it's past traversal issue. So basically, IRIX, which is with your friends and colleagues, people who might be interested in the topic, please do this. Sorry guys, I can hear myself. Okay, thank you, Rick. It seems like we have some progress on LinkedIn. If I basically did that, if not, it's okay. So first of all, you're definitely right. So the API security as a topic starts from a while. So it's not like the let's say something that they show up yesterday. However, a lot of exploits, it just coming in its rate and start. So basically the threat is very, let's say, actively spinning, and we can basically analyze API security as a mainstream start from 1999. It's not correct. However, the first one was there. Moreover, the same exploits as this one, like a path traversal or injection by OWASP API top 10 or OWASP API security. And by the way, we will discuss a lot about OWASP to this OWASPs during the session. It still happened. And last time when we saw that, and actually the same dinosaur exists, it was like just a relatively couple of months ago, April 18, was a WSO2, which is a kind of like standard de facto in API gateways and API management systems. The same exploit, exactly the same issue, exactly the same vulnerability, exactly the same injection with almost equal payload happened like whatever in 23 years after, 24 years after the initial exploit. So the trend is still with us. And I specifically want to focus you on the injection side, because injection is still the main threat and the main bad actor across among all this API security exploits types. I will explain why, but that's just a good alignment for all of us. That first of all, we're dealing with threats that existed. Some of them existed a while ago. Some of them are brand new. And I'm here today to discuss this evolution and from where and to where it goes. Again, thanks everyone who voted, and thanks everyone who joined us today. It's 150 people online. Really appreciate your time. So what's under the hood of this API? So first of all, it's wrong thinking about APIs as something that only available in the public to organize this like internet-based access. It's not correct. Nowadays, every single piece of the infrastructure, internal or external products, at some point using APIs. Even whatever, the recent exploit was Microsoft Exchange clearly identified that we have kind of a very legacy APIs with a software that we know for years And at the same time, we have like new software like Kubernetes that using APIs, and they then rely on their APIs to build our APIs, basically multi-layer things. And this slide, I just want to highlight that it's not the API world. It's not only about the public APIs, but also partners APIs connected with whatever double site TLS connections with a mutual SSL, with a mutual TLS, with certificates and stuff, and also the bunch of the private APIs, including software like GitLab, software like Kubernetes itself, software very deeply connected with infrastructure and basically defined infrastructure. Overall, there is a 58% of all the APIs used by a team in the company still private, which means no access to the internet, and only 15 of them public, which mainly the focus of security teams. So you have to think about API security as a wide spectrum of APIs, not only public APIs. That's a very important thing. The second thing, and the second point that I want to bring today, is just how big is the threat. So we're tracking this API exploits daily and hourly to then build this quarter reports specifically related to the modern API threats. You can find this Q1 and Q2 report, and Q3 report is about to publish. Look at the website, wallarm.com, to the resource section and section on the website, top menu, and then find these reports. We're tracking them daily, and then we're also tracking them from early beginning, since like 1998, as I mentioned before. We tracking them carefully. Now we have this exponential growth with mainly 5 new exploits a day, and we're counting only like something material in the report. That's why you can find less than 5 a day in our reports, like 3-4 a day sometimes. But in fact, it's 5 API-related exploits a day that happen there, and it's exponential growth. At the end of the year, we probably will see more. That's why it's very important to see the threat. And it's not something that can be, let's say, manipulated or somehow modified. This is the data that we gathered by CVE's analysis. The API security is a trend, and the trend is growing. Then, which is very important part of this analysis, we also want to align this with real threats, with real data breaches, with real incidents. So first of all, a lot of companies, not only Wallarm as a cybersecurity vendor, but Verizon and the Gartner and a lot of analysts predict that APIs will be the main threat for the cybersecurity in 2022, technically this year, which actually happened. Yep.
Sorry to interrupt.
Sure.
Restream finally kicked in.
Cool.
So you are live on LinkedIn. It's going to be a little awkward to catch people up, but maybe just give a quick recap of where we were.
Yeah, cool. That's great. You guys, thanks a lot. Thanks, Rick, to handling the technical issues. I'm really sorry for everyone who watching us on LinkedIn. We're not starting from scratch there. However, we're finally there. That's great to see all of you. And for the people who is here on Zoom, thanks a lot. Just keep tracking us on Zoom. It's 150 people here, and I don't know how many on LinkedIn, but I hope that not less than 100, right? Should be a bunch of people there. I see 40, 45, 50 people. That's 200 of us all together. That's just brilliant. Okay, so as I said before, API security is a real threat, and we have the data about the 5 exploits a day that grow exponentially. We have a lot of reports and signals from analysts and companies like Verizon, cybersecurity vendors like us who track the exploits and stuff. And now, which is the most important thing here, we have a bunch of incidents that already happen specifically related to API security. And it's not like, let's say, SMB companies. It's a huge companies like Uber. I mean, Uber is a bit different thing, right? Like, let's say Verizon, Starbucks, the Venmo, Instagram, and T-Mobile. Like, a lot of things happen specifically related to API security. And then we just need this analysis to finally combine all the factors and claim the following. So first of all, this is a Verizon threat. We have 5 exploits a day. A bunch of Fortune 100 companies and very well-established companies with a huge cybersecurity budget got affected, and unfortunately, data breach happened. And then we have the good signal from analysts and the companies who is analyzing data and tracking the basically threats, that the threat is real, and we have to get that. Okay, so again, we're here today not just to describe that API security is a real thing. It's not about that. We're mainly here today to discuss from where and to where it goes. So I just want to start with a quick overview of this 20 years of evolution of API technologies from legacy APIs, also known as web apps. And here and there, I've just dropped in the point that technically web apps, it's still legacy APIs, CGIs apps, it's still legacy APIs who analyzing the URLs and producing HTML outputs, but it's still APIs at some point. And at that slide, I just have this quick recap or like to where and where it goes. Again, I put this 2000 as a reference point because we have the first API exploit for the folks who missed the first part, detected and released back in 1998. So that basically a while ago, 24 years ago, we found the first API exploit, and in 2000, we just like the technology itself moved us from the legacy web to APIs. And again, I want to count web apps and CGI apps as just legacy APIs. So from where and where the technology goes. And again, definitely cybersecurity, it's in ideal world, we have to be more proactive. In real world, the solutions actually comes to the market like only after the incidents or the real threats, and definitely after the technologies inside, right? So nobody will build cybersecurity solutions before some kind of technology actually available for the wild market, because like you don't have a market, this is for sure. Economy-driven issues, right? So first of all, we started with a kind of dynamic websites and static websites and CGI-based web. And by the way, if you still remember what's the CGI, just give me a star on the GitHub or push the like on LinkedIn. So if you as old as IELTS, right? So we started with dedicated servers. We started with one release a month, so even less, and then issues like SQL injection and XSS and stuff like that, and instantly bring the solutions like WAFs, which basically analyzing traffic, applying some regex, and if the regex actually match the request, that blocks the request. Now we have a bit different story. So first of all, in today infrastructure, we have much more sophisticated tech stack, not just like one framework or two frameworks or one whatever operation system or two. We have a bunch of them. We have whatever RDS. We have the bunch of databases. We have a bunch of frameworks. We have a client side and server side separately and stuff. Instead of the CGI scripts that produce directly HTML for browsers by analyzing URL data and URL parameters, we now have the full-size APIs, serverless, single-page apps, a lot of things that happen there. Then we have multi-cloud and private cloud environments and managed cloud environments and solutions like Kubernetes that basically way behind the operation system that can manage containers, and you can run as many containers as you want. I mean, as many resources you have, and releases every single day, because we have to tune. We have like the digital marketing and other initiatives that basically run this product releases very fast. And we have a bunch of other threats like server-side request forgery, which I was actually lucky to discover like a lot of time ago, and then XML external entities, and then API specific threats. And basically, obviously, the WAFs and regex doesn't work in this environment. But again, like every single time when we're talking about evolution or some next generation something, we always like first have to think about the technology itself. The technology actually the first, and then cybersecurity, and they come to meet these requirements. API world nowadays, it's a bunch of technologies. I just put some of them here. There's protocols like GraphQL and WebSocket, like HTTP2, gRPC, and not only technically HTTP now define API and API security landscape, and like count gRPC, count WebSocket. It's not web protocols at all. So it's like the binary protocols. We have a new technology stack like service mesh and serverless and Kubernetes and multi-cloud, Jamstack, Envoy, NoSQL, whatever, a lot of things that happen around. And this stack that basically define completely new landscape. So we have to basically work with a new reality, and this new reality dictated some different controls. And the most let's say, knowledgeable and known controls related to and risks mapping related to API security, definitely OWASP API security top 10. So what we have now, we have two different OWASPs that basically define that. And again, like OWASP also make their own evolution from the generic web OWASP to the API related OWASP. So that we have this OWASP evolution. We have now two different OWASPs, like OWASP top 10 that's applicable for applications and also applicable for APIs. It's very important. Don't forget about that. Technically, you still have to count OWASP top 10 threads for APIs. And then more specific OWASP called OWASP API top 10, specifically applicable for APIs, but also applicable to the legacy web or legacy APIs. You should not just forget about that. In fact, to deliver 360 API security, we have to deliver both OWASP top 10 and OWASP top 10 APIs. And we need to deliver that for legacy and modern API stack. And then, for instance, if you have an SAP, right? So what should be more legacy than SAP? It's an ERP system, very good known, right? Well known and very good itself. I spent my 4 years to deliver this SAP PI for oil and gas companies. I know that a while. And then I still remember what is SE80, if somebody like remembers SAP. So in fact, you have to take care about OWASP top 10 risks for SAP endpoints or ABAP stuff, and then OWASP top 10 API as well. So it's not something that you have to forget about that. However, some of the people specifically from cyber who recently joined an industry count that, so I got this OWASP API top 10 covered. I don't need to care about OWASP top 10. It's legacy. It's only for legacy. No, OWASP top 10 still applicable for APIs as well as OWASP API top 10 still applicable for legacy web and legacy API. Just count this. This is very important and means that OWASP top 10 can't replace with each other. They actually exist in a parallel. So we doing this reports, we actually track an API exploits every single day, every single hour. We have this notification in Slack to then grab them and push this to the statistics and issue these reports. And then we have this mapping between OWASP top 10 and OWASP API top 10. So if there is a API exploit that we know, we can map this particular exploit by payload or by impact to OWASP top 10 or OWASP API top 10. As a result, we have this mapping and a heat map. So first of all, the borderline here related to more exploits, and the percentage here also related to like how many exploits we saw during the quarter. This is a Q2 data, and there is a mapping between OWASP top 10 and OWASP API top 10. However, don't count that if something not mapped like this one, we don't have the threats. We analyze in only 1/4 of the data, and then this types of risks also have some overlaps, right? That's why you have to care about that. So, and again, this mapping is mainly related to exploits itself, how they can make an impact on your systems, and not only to the class-to-class mappings. Overall, injection is the main threat. This is for sure. So we're analyzing this quarter-over-quarter, and like every single third exploit there related specifically for injections by OWASP top 10 and by OWASP API top 10 even more, because this class is much wider. And then the OWASP API injection also includes some server-side request forgery attacks and sometimes integrity issues if it comes to the injection exploitation and stuff like that. This is definitely the major class. That's why all the time when it comes to the API security, you have to start with injections first and then take care about BOLA and all the rest of the things, which is, by the way, also have the very solid mapping. If you want to download this report, please go to the Wallarm website, click it to the resources part on the top, and then get your copy of the report. You can find the Q2 and Q1 data as well. So now we want to run the second poll, mainly related to what's your current cybersecurity stack and how it looks like, which kind of solution to use.
I'll launch this in a sec, but we're getting a bunch of questions. So thank you all for being engaged. There's a lot of good ones. I'll get to your questions either on the applicable slide, because a lot of these we're going to get to. Other ones we can answer at the end. But a good one now is just kind of a overarching question, which is what percentage of reported API vulnerabilities are detectable?
That's a really good question. So I want to start with how many of them exploitable,
Yep.
right? The first of all, we track and we add into the report only exploitable issues where we definitely sure that exploit exists and it can take some damage.
Yep.
Related to the detectable, if you asking about like automatically detectable or like detectable at all, it's a bit different point. As an expert, I was able to detect pretty much every single exploit for the last quarter. However, if I know where to find that, right? If it's not there, I mean, I can say that 100% to be completely honest, and it's always unanswered comes to the manual analysis. It's also the question and the function of the time, how much time I have to discover them.
Yep.
Cool. Okay, do you have any other questions?
I think that one fits there. I will get to all the others. Like I said, please keep them coming. There's a lot of great questions in there. I'm not ignoring them. I'll try to fit them in when they seem to be applicable. So why don't we launch the poll? Next one.
Yeah, let's launch the poll.
So it is launched. Let's give it a minute or so. So again, question is what currently is in your API security stack?
Yep.
And there we go.
And if it was, do you have any like cybersecurity solution or in-house, let's say, function controls or whatever that specifically cover your API security at some point or not? We push like 7 different options here and feel free to vote. And again, we really need the data you shared. It's good to have it all the time. Let me just check if I can see the poll result.
I think when I end the poll, I think I can push you the results. But we are currently at 70 answers out of the 133. I'll give it another, we'll say 10 seconds. We're getting one last push.
Okay.
All right. I think we're hitting, oh, nope, kicked in again. All right. Give it 5 more seconds. I think we can get to 100.
Sure, let's vote. And I see 70 people on LinkedIn and 100, whatever, 50 here. That's a lot. 200 of us online. That's a small conference technically. I remember the first time when I see the result of this poll. That's great. First of all, yeah. So 67% of the people there actually rely on API gateways, which is a good option. The first of all, and you be surprised, but I have specifically a slide dedicated specifically for API gateways. That's a good option. So they can deliver threat prevention, but that's a lot of things that you can deliver using the API gateways, including simple rate limiting and authentication authorization controls and even compliance checks. And the WAF, 20% for the WAFs. The WAFs are really not good with APIs. So I'll explain why. And like you can cover a part of them, specifically OWASP top 10 risks, but like if you definitely want to deliver API security, something better than a WAF. And single sign-on, by the way, authentication tools like 48% of technically half of the audience. NGWAF WAAP 16%, API security 24%. That's a well-educated audience, or market is much bigger than we're supposed to. And the custom internal tools 20%, using less than 4%. So what I have to mention based on the data analysis I see here, as we have a very educated audience here with a lot of tools implemented, or some liars. Okay, what's next? So yeah, so I just want to explain from where and to where this API evolution in terms of the security solution goes. Basically, we have 2 different evolution tracks. The one track mainly related to OWASP top 10, and it basically comes to the upgrade from WAFs, which apply just regular expressions to request to WAAP, Web Application API Protection tools that can do more things, including like the API schema validation for REST again, APIs, not only REST, we have GraphQL, we have gRPC, WebSocket and stuff. They're not really good there. However, and some of the vendors also moved from regular expression to some more mature and sustainable detection logic. So this is one evolution track. And then we have another one track called API security. It's mainly brand new companies that born from scratch based on non-inline analysis, mainly post analysis and incident, let's say, response after the issue comes. They specifically focus on OWASP top 10 with very limited coverage of OWASP top 10, not OWASP API top 10 thing. However, they can cover different things, including BOLA, by their detection and then be integrated. And our goal as a company to build one unified solution there to basically merge these two evolution tracks in one unified product that can deliver API security for all the API protocol. That's our goal. But overall, that's what we have on the market. And that's a very important thing to know. The WAF technically now moved to WAAP, and there is a completely independent track with completely independent brands and vendors specifically started with an API security standpoint. So what's wrong with existing tools? So we have a bunch of different products, and my goal for today is just to explain where they are good and where they are not. Everything starts from WAF, and I intentionally put WAAP to the same bucket since it's just like next generation or the evolution of the same tools with the same logic, detection logic with the same core inside. Historically developed to protect web apps, and they don't have the API protection at all. And then now they're catching up with introducing some kind of features and changed the logic and parsers and stuff. Those are the 5 main limitations. Definitely, I actually never mentioned kind of like 8 kilobytes per request analysis for Amazon WAF or something like that, or Cloudflare, says they can analyze even like requests and full. It's out of scope. However, it's a fundamental limitation for all this cloud WAF. They basically can see entire request body, and they're limited by 8 or 16 or whatever kilobytes only. I'm mainly this slide mainly related to fundamentals of the limitations. So first of all, it's not that easy to include non-web protocol to the solution initially designed for web traffic analysis. WebSocket is a streaming protocol. gRPC, it's also like a completely different binary protocol. It's not that easy to just push these parsers to your HTTP kind of web server agent and hope that you will have some kind of level of security. It's not that easy. It's not even close to that. The secondly, lack of API, OWASP API top 10 prevention capabilities, specifically when it comes to request correlation analysis and authentication analysis and business logic flows and stuff like that. Since WAFs initially designed to analyze data request by request and make decisions real time based on this request data without correlation with previous this historical data or some other things and scores and whatever. They have rate limiting, they have like thresholds and stuff, but it's a bit different capabilities. And then lack of API vulnerability detection, right? So the WAFs itself, to discover and to protect efficiently against OWASP top 10 things, OWASP API top 10 things, you have to discover issues. It's not enough to just implement the kind of shield and like rely on this shield. You have to actively check what's going on with your APIs and block threats specifically related to issues that you discover. And that's why, by the way, we introduced the Wallarm as a product, as a name. Wall with an arm, with an active part of the product that can make sure that everything is good and find issues. And then there is no API discovery features or PI discovery features that's just very important for API security. You have to discover where you have to focus your security. You have to discover how your API actually works and protect them and apply only applicable rules and applicable controls to every single API endpoint or even API parameter. And then there is a bunch of, as I said before, a bunch of this internal and partners APIs that not just covered by WAF, because WAFs initially designed to protect something public-faced against like public threats that came from the, let's say, wild internet with the IP addresses and stuff, and counts with whatever partner API. You have just one IP address with a bunch of banks with their own certificates and stuff. If you're a fintech company, internal APIs, everything is different. You can't just block like the 10.0.0.0 subnet and rely on this protection level. So that's that. By the way, that's why WAFs can't really help there, and even WAAP very limited. As the next, then we have an API gateway. So
Hey, sorry, Ivan, can I interject? Go back to the WAFs. We have a question
sure.
From Pablo. Are there on-premise WAP solutions? The WAAP. If I think
No, WAAP, it's basically the same nature as WAFs. It's mainly cloud solutions or cloud native solution that you can deploy in the cloud and analyze. But usually a bunch of vendors who now came to this WAAP market, they only cloud vendors. That's why they can't protect internal and partners APIs at all. That's what I mentioned in point number 5.
Yep.
WAFs go in cloud, this is for sure.
Okay. Thank you. Yeah.
And all the mature WAF vendors, they're all in cloud. So that's also true.
Okay.
Okay. The next thing, the API gateways, API management gateways, stuff like that. What we have here, first of all, this is a really great software designed for different things. These guys, they're not security solutions, and don't count API gateways as a security solutions, as well as management solutions. They're designed for the different purpose. They compare API gateways is close to the load balancers, right? There's a bunch of features, including rate limiting, including like session control even, or AP control or whatever, which specifically related to security, but the load balancer is not even close to that, as well as API gateway is not even close to API security solutions and or WAAPs. However, you have to use that if you managed API, let's say, architecture. However, a lot of APIs still unmanaged, and it's really hard to push your GitLab or Exchange under the hood of Conk or WSO2 or any other API management solution to extract this authentication, authorization, rate limit, and different capabilities. That's just really hard to deliver, right? So main 3 limitations there: no threat prevention mechanism. They can't stop threats, and they can't like stop SQL injection attacks and stuff like that, or they can't detect the malicious GVT token or lack of the GVT token control. There is no business logic flows control. So if something goes wrong, it goes wrong, and APIs for API gateways and API management solutions, just like stateless apps like request response stuff. And then no discovery beyond themselves. So they basically can discover what's going on by just traffic analysis. They have to rely only on these definitions, like you have to upload specs there or define your APIs, and then gateways will be able to manage and proceed with them. And then API security solution. There's completely new players on the market, which is very few of them. By the way, at some point, including ourselves, but like we run in Wallarm since like 2014, running a lot of things there. It's still limited. First of all, there is no attack prevention things like in real time. It requires manual analysis and direct data access by vendors, since it's still new companies. We're not asking for that. By the way, Wallarm can work completely on your site and analyze data on your site. We never require access to the data by our analysts or other folks. There is no like solutions like that. We don't like that idea. And then they relies on other solutions in terms of mitigation, meaning they have the same inherited WAF issues. So if you rely on somebody and this somebody can't actually analyze gRPC data or WebSocket data in full, they can't protect. Even you will discover they can't protect. That's the fundamental issue, and specifically that's why we're building our own solution that they basically combine API security and WAAP capabilities in one unified product called Wallarm. Okay, so then I just want to switch for some API security framework 2023. And guys, I think that we have to finish in like 10 minutes to give some more space for the questions. Feel free to ask questions directly on LinkedIn and or Zoom session in the Q&A stuff, and Rick will help me to sort, arrange, and then combine similar questions and address in a few minutes. So overall, to deliver API security, we have frameworks. A bunch of them existing. However, they're all similar in the following steps. You have to discover like assets management for whatever, and assets management should be initiated by discovery. And the same thing is with APIs. We have to discover API endpoints. We have to discover API products, API-driven products, including legacy, SAP, Exchange, everything should be discovered first. Otherwise, we don't know how to protect. And then find either external or internal, right? If there is an API and there is a way to communicate directly from the internet with this API, we have to know about that. If it's a partner API, we have to know about that and which partners have an access to that. If it's an internal API, it's a GitLab with a bunch of exploits that's released every single day. We also have to know about that and know where my GitLab is installed, how to protect once the new exploit will be released. And then data classification and risk assessment. We have to find what's the risk posture. We have to find if it's exposing sensitive data, any misconfiguration and stuff, to prioritize, arrange, and then take actions. And then only after that, it's possible to put security controls. We have to put security controls to make sure that our API or app protected at all, then how it's protected, which kind of threats we can stop, and do we have visibility for that to finish the framework. It's very brief and very generic concept, and the framework consists of 3 steps. However, it's good to have it in place and don't try to initiate products without that. Please make a screenshot if you want to. It's a very important part. However, we will share the deck for all the participants who actually sign up with email, and there is a record available on LinkedIn. You can find it there. Okay, so everything starts with a discovery. Discovery is just a very important piece, and it's starting point to build any cybersecurity program or controls related to API discovery. And then, first of all, we have to address where are my assets. Then we have to find what are the assets, and then are there any problems. So all of these issues related to the discovery stuff. We have to find endpoints, API endpoints, protocols, like specs, if we have that, like documentation, whatever, specs and policies, if they exist. Then discuss if there is any services or some kind of like environment relations things, if it's staging API or production API, are they maintained by SOTI or maintained by us, and then find authentication, issues, vulnerabilities, and misconfiguration. That's the discovery phase. And we have to, basically, once it comes to the discovery, we're mainly thinking about like 3 different buckets of like unmanaged APIs. So first of all, it's shadow APIs, completely new APIs. You don't know about that. That's my favorite part, because like sometimes some service like Exchange became like shadow APIs for the companies. The companies just don't know that my Exchange used that a couple of years ago. GitLab surprised me that they have a GraphQL endpoint that I wasn't aware about and stuff like that. Then we have a zombie API. It's a kind of deprecated API that should be removed, but actually still alive. We all know that it's done, but it's actual and up and running. And then we have legacy and used APIs that but should not be used by your users. So that's 3 buckets and funny icons that can bring your attention, but please be sure that you know how to track your APIs in the right way, and you know how to basically stop threats there. Everything starts with the discovery, and this is a good part. Rick, do you have any questions? I think that I heard you.
Nope.
Okay, got it. Just a few examples how we delivered this API posture management for one of the large fintech company. We started with following technology stack: Amazon AWS and APG and Kong. It was like 4 different challenges, mainly related to controls and our data specs. And then API security was on the top of their initiative because of some internal priorities. And we just delivered that and found that now they have the full inventory based on actual usage within just 3 days. And after the 3 days, Wallarm was able to discover all the endpoints and find how many of them handle API data. And then product security team was able to basically prioritize security efforts and update them in the right way. That's the real case that we deliver for the fintech, and that's specifically happened in just 3 days. So what's next? The next part is how it looks like in detail. So discovery, I mean, all the discovery solutions pretty much similar, and there is open source solutions like API Clarity, by the way, by Cisco. You can download it and try. Open source, you don't necessarily need to pay. And then they look similar. We analyze and traffic, we discover endpoints, and then classify these endpoints and APIs, external, internal, PII, and track changes. If there is a new API, new endpoint, we will highlight that. If it's an old one, a legacy, we'll highlight that as well. And then the second part, the second piece of this API security controls to where we get this evolution process goes through as the classification and risk audit. It's very important to not only find endpoints, but also classify data there. If it's like the personalized data or personal data or financial data, credentials, technical data, and how to proceed with that. That's how it looks in our case, like, and the others very much similar. We have some kind of requirement parameters in the request and responses, and then or mandatory parameter and optional. So we have to track them all. We have to make reports based on that, and overall make sure that our customers can basically click one button and find all this like PCI DSS related endpoints with PCI DSS related data and or healthcare or HIPAA data. The other thing, as I mentioned before, the PII detection. So we have to make sure that if we know APIs and data, we also should take care about the whatever credentials like passwords or secrets or token or sensitive data like financial data, bank accounts. Also the same part and very important for the classification and discovery phase. And then assessment or scoring. Once we know issues, we have to be able to sort and prioritize our daily job, make a backlog for security team, right? To do so, we have to track issues and we have to introduce the kind of scoring system that the customers can configure, and as a result, find the way how to like work with these issues one by one. That's what we introduced, like the other systems very much similar. And then apply controls. This is the most important part, right? The WAFs basically just controls, and we have to apply them in the right way. So overall, there is a different controls that we discussed from different angles. It's visibility, detection, and mitigation or remediation. The visibility, we spend some time for that. You have to discover, you have to know your attackers, you have to discover from where your attackers connected, which kind of sources they used, like is there any whatever Amazon assets that used by attackers? Is it like the big botnet, or it's just like random machines all over the world, PCs and stuff? We all need this data, and this should be visible in the system to then make the cybersecurity team act on it. Then the detection logic. It should be definitely possible to identify OWASP. It should be top 10, then OWASP API top 10. Again, OWASP top 10 also applicable for APIs. OWASP API security also applicable for legacy web. Don't forget about that. Then weak tokens and credentials specifically for APIs, authentication, authorization problems, and a bunch of more. And then detect and act. Mitigate attacks in real time. Very important. Nothing more important than just be able to stop the threats. Specifically when it comes to the 0 days or like 1 days with widespread exploits. Then provide engineering team an actionable feedback and insights how to fix that, and then prevent issues like API abuse, credential stuffing, which is a part of API abuse, or brute force, or scraping, or API bots. So which also should be detected and then remediated. So without these three pieces, it's very hard to think about controls. If you have only detection covered, you will not be able to remediate or mitigate. It's nothing. If you have only visibility, it's good to have. However, your team should take care of that manually, which is a lot of job. So in our case, the protection looks like that. So we have the basically built-in WAAP and API security modules under the hood of the one product. So it's basically the systems that work all together as a one unified product. We analyze traffic, all the protocols, including REST, SOAP, gRPC, GraphQL, WebSocket APIs, and stuff. Also, stop threats like API abuse, level 70 DOS, including logic bombs, zip bombs, long HTTP requests, bots, whatever. Also, stop OWASP top 10 and OWASP API top 10 threats. And then it's tuning in real time based on the detection logic, based on grammars instead of regex. By the way, the library is available on GitHub. Go to the github/Wallarm/lib detection. You're able to find the libraries there. So, and then respond. So it's not only, it's important not only to protect, but also respond to threats. To do that, we group in attacks by different attacks groups to basically minimize the manual job of analysis and grouping. Then we have in-depth attack insights, including like what's going on, every single request, we decode data on the fly, including JSON data and base64 data. We're able to find what's going on there. And then we have a bunch of integrations with SIEM, SOAR, incident response, and a lot of tools you want, including our own APIs that you can use. That's a brief overview. And again, like that's what you have to have in terms of the API security. And then overall, and in a few words, in the 3 sentences, we deliver complete coverage for full API protocol support, including gRPC, SOAP, non-HTTP web and APIs based on real-time grammar parser. It's better than regex, so it's much better in terms of performance, and the level of false positive is less than API abuse prevention against preppers, botnets, and API bad actors. Then complete visibility with an API discovery, the track changes, PII, and a lot of other things. And then fast time to value, which means cloud native delivery in cloud, out of band by just traffic analysis in the mirror and inline agents as well. So we have all these things covered. So that's almost done. Thanks a lot. A couple of things more about our company. If you need a demo, just sign up on the website. We have a free tier, 500,000 requests a month, 500,000 requests a month for everyone. Just sign up and you will able to deploy system in full, look at all the features, and don't pay us at all. It's a free tier for everyone. And that's just a couple of things there. Join us, join the company, really good customers we have in place. Thanks a lot. If you want to see the demo, look at the us1.my.wallarm.com/sign up and get a free tier here. If you have any questions, just let us know by request at wallarm.com. And then let's proceed with the questions we have here. Rick?
Yeah, we definitely have a bunch, so keep them coming. First one I'm going to go to kind of goes back a little bit with understanding the APIs. So how do I understand which APIs are zombies, and how do you discover if it's unused? Is that based on Swagger, similar scheme description?
Yeah, so first of all, that's a really good question. But I can show you this couple of screenshots here to basically align with what we have in the product. Yeah, you can find here that we track and changes. So all the time when we see the traffic that ask API for something, an API reply, which is very important. We also track this responses and the response structures. We can make an assumption that an API is active, up and running, and it's actually used. If it's there, it's not used, it's kind of zombie, right? So you have it, but nobody uses them. You have to care about that. And then we have we also know how the previous, let's say, version of this API, the previous Swagger schema, whatever it looks like. It's not only about Swagger, because we have the GraphQL, gRPC, and different protocols out of this like Swagger specs at all. We're tracking them and then compare to where it goes. If somebody changed an API request structure, added new parameter, we know about that because we see the previous, let's say, model, right?
Okay, thank you. Next question comes from Bikesh. I hope I said that right. Will the API security also prevent botnets or DDoS attacks? And then he makes a little bit of jump. If yes, then we don't need a SIM solution, maybe?
It depends. So first of all, when we're talking about DDoS attacks or bots, some kind of behavioral-based things, everything rely on the particular attack you faced with in your API structure and your business needs. If it's like, if you're the e-commerce, it's one thing. If you're kind of airlines with a bit different endpoints, with different things, with legacy clients, it's a different thing. If your API that basically serve only like mobile apps, where you can push your SDK and improve this phone controls, identity controls using TPM, it's one story. If your API should be open, it's a bit different story. So everything is just well interconnected. In a few cases, definitely you can just deploy solutions like Wallarm and don't have any issues with bots. And real cases, so you have to think about like who attack you, how, and which kind of endpoints you have, how many of them just like very legacy endpoints. If you have a capture or some kind of like old-fashioned mechanism and you have to have it in play, start with it. It's a very complicated question that basically rely on particular objects that we have to protect.
Yep. Thank you. So got that one. Take the next question from Bastian, and it's specific to the use case you had brought up. So when you say Apigee infrastructure, does Wallarm protect the API hosted on Apigee?
We have an APG connector. In fact, if you have an APG, we have our own connector that can copy data and send to the Wallarm for analysis and receive them back. It can work in synchronous and asynchronous mode. We use an APG as an example of the data connector for us. And related to the particular case, we actually deployed inside infrastructure to protect not only the public faced or APG covered APIs, but more of them. And the most typical deployment option for us is inside Kubernetes controller. So we have the ingress controller module. If you're on Kubernetes, the best way to install us to install it there, because the Kubernetes then can cover everything.
Okay. Actually, I'm going to skip to this one because it's a follow-up about the zombie API one. So he made the comment, sorry, this is from Vitaly, unused APIs are not always zombie, right? The API can be valid, but temporarily not in use. So do you have any other criteria to detect zombie API in addition to just the level of demand?
That's a lot of them. That's a lot of them. It's not as easy. And usually when we discussed about like how to detect the zombies or shadow APIs, it's all the time question about statistics, how to build the statistics, how to build the model, and what's the threshold for the variation of that. But overall, you're right. So that's more than just one criteria.
So we got, I'm going to skip to a couple of, we have a couple from Anonymous. So I'll go to the first one, and it's kind of around more of a, I think a little bit of a dev question, which are, what are some best practices to just secure development of APIs? Are there any frameworks to be followed?
The one of the frameworks I just mentioned, right? Exactly the three. And I even asked the audience to make some kind of screenshots or then get back to download this the slides in full. And that's how I see that, the three steps that you have to cover. However, everything actually now rely on like what you have inside. If you kind of like Fortune 100 company with dozens of their own data centers and servers there, your framework will be a bit different. If you're a newborn startup with all in Kubernetes with just a couple of APIs, all well documented, with all covered by REST or GraphQL, it's a bit different story, right?
So the next anonymous question is, what are the manual check to be checked or performed prior to using tools to secure an API?
Oh, first of all, just look at the access logs or any other data you have related to who call your APIs and how, internal logs, Sentry, whatever you have, and then compare just URL by URL or somehow else with your Swagger or documentation. If you will see 100% coverage, 90% coverage, you're good. If you will see 80% coverage or less, you're not good at that. You have to improve your doc specs, and you have instantly will find the blind spots. It's a good manual exercise that basically everyone can make.
Yep. I got one last question, but I'm gonna save this one for last. So I'm switching over to LinkedIn.
Yeah, I hope there was a bunch of questions there.
I don't see any questions. There's a lot of comments, but no questions. Actually, so I'll go back to this question. Hold on. All right. I don't see this question. Let me go back to here. Oh, we just got another one come in from Tansi. How can we harden our APIs?
Sorry, how what?
Harden APIs.
Oh, that's a good question. First of all, you can implement controls based on your Swagger specs, right? We have an open source product called API Firewall. Just go to the github.com/Wallarm/API-firewall, and you will be able to find the product. It's written on Go. It's completely free, open source. You can apply hardening based on that thing, and it's an easy pick. And then the best way just to define your specs and define right policies right inside the Swagger, and then apply that. This is for sure That's what you can do for now. However, it's not that easy to harden things like access control and or rate limited and stuff like that. There is no places for that in Swagger, in a generic Swagger things. And you have to use your API gateway or load balancer or whatever you have to make that happen. However, it's a good starting point to use open source API firewall.
Okay, just scrolling through, making sure I'm not. Oh, looks like we do have. So we got a couple questions.
And by the way, sorry that we're out of time. So we spent some time to fix some kind of like technical issues.
So we appreciate everyone who is staying on and getting this. So someone from LinkedIn, what was the open source tool you mentioned for API discovery?
It's called API Clarity. So we will share all the links, and unfortunately I can't basically switch my screen since I'm sharing it, but then I'll share. It's API Clarity and then open source API firewall. These two tools that I mention all the time.
Yep. Actually, so we have another question from here, and it is, what are some free open source tools that you recommend?
Mm-hmm.
So
I mentioned two.
Yep. So we got that. Then we also have, actually, this is an actual product question for our product, which is for licensing, and I'm assuming this is for us. Will it be per API or is it tenant based?
We charge by amount of requests a month. Technically, never mind how many APIs you have. The only thing that does matter is like how often people use them. Basically, amount of API requests a month.
Okay. We got another question. I'll go for the one from Maxim on LinkedIn, which is, does the size matter? How do you handle coverage of the visibility and control enforcements across large environments?
That's a good question. First of all, how large is your large?
Yep.
So one thing is like hundreds of hundreds, and the other thing is like dozens of dozens. So that's relatively large. And I think that the most important here, it's not only about the question of the size there, but like how variety is there? How big is the zoo? How many animals you have in a zoo? The size of unique creatures define the real scale. And if you have the many different things in one place, that comes to the headache.
Yep.
And by the way, that's why we decided to build our own product based on this basic idea. We have to protect every single API we know. Never mind if it's gRPC, GraphQL, legacy API, SAP, Exchange, or custom APIs that you build based on REST, or non-CRUD REST, or the WebSocket thing, which is the case for let's say Forex companies, for instance, with the streaming services, right? So we want to protect them all. And to do so, we did a lot of job to make this happen. Okay.
And quickly getting to Arthur's question, and I'm sure everyone, and I get asked it a lot. This is kind of housekeeping. We will be sharing the slides and sending the recording both to everyone who's registered and participating on Zoom, as well as we do have the ability of, when you signed up for the LinkedIn Live, we are given your emails. For those of you that have opted out, we will still send you the slides and the recording, but that will be the only communication you'll get from us. We respect your privacy. So quickly, though, getting back to a question here, is there anything more sophisticated to authenticate an API than MTLS?
That's a good thing. Again, it depends on like what exactly you want to do. MTLS, it's just like one of the options. So definitely the main thing is like which kind of problem you want to solve. If there is a kind of like the partners APIs where you don't care about this the keys at all, and it's not like mass distributed, MTLS probably is the best option. If it's kind of whatever HubSpot or like public APIs, probably OAuth is the best option for you. or JSON web tokens is better for you. Depends on like how you want to authenticate your clients. I mean, it's not like an easy answer since it's multi-dimensional equation to find what's most convenient for you. But if it's a partner's APIs, I think that MTLS is the best option for sure. And mainly because a lot of clients support them. So you don't need to install any software to establish this like mutual SSL. You can use even URL. That's a very important thing.
Okay. Sorry, switching between screens. Where'd my questions go?
Okay.
So we did get a question, and it seems like there's a similar question on LinkedIn, which is, how do we decide between, best of breed solutions, meaning something specific for API security, some specific for WAF, so on and so forth, versus a single platform? What would be the decision criteria on that? Or how do we decide, right?
Again, the price standpoint, right? Everything now depends on like how fast you have to deliver this project. Like, can you just wait till like it will be deployed on scale, or you need to make everything happen like as soon as possible? What do you have in place now? How to integrate with that stuff? It's not an easy answer.
Okay. One. Man, too many screens. So we just got another one. What is the disadvantage of using the load balancer as rate limiter on internal APIs?
Nothing bad with that. The only problem is like you still have a bunch of internal APIs that you can put under the hood of the load balancer. Check your Microsoft Exchange if it's there or not, right? However, rate limiting is an interesting animal as well. So you have technically, if we're talking about the IP address-based rate limiting, so I don't think that it's a good idea to protect internal APIs this way, since you, in a lot of cases, you will see just one IP address, and it's going to be internal IP address or just very few of them, right? I don't think that like it's as easy as you mentioned. However, it's a good option to start with. And in real case, we have to implement like session-based or API token-based rate limiting, which is the task for API security solutions, not API gateways, or even not for load balancer or even API gateways.
Okay, I think, yeah, when we're already 10 past the hour. Again, I apologize to everyone about the technical snafu, why we're running late. So as always, we will be sending the slides and presentation as soon as the recording is delivered to us and cleaned up. So that'll probably be roughly tomorrow afternoon. You should see that in your email inboxes. Appreciate everyone's time. And as always, you can email the request at wallarm.com or go to the contact us page on our website, and we will be more than happy to engage with you. Ivan,
yeah, thanks everyone who joined us today. Please follow us on LinkedIn, our Wallarm page. We really need you there. You will be fine. We will be able to find all the updates and next events. Plus, don't forget to look at the free tier that we have online. If you have any questions with API security, just email us at request.wallarm.com. Thanks a lot for the session, and have a great weekend, everyone, right? It's really close. Bye, guys.